Hi everyone, welcome to the first video of our course Introduction to Data Science using R. So this video is part 1. Let's see the outlines for this course. First of all, we have EDA, that stands for Exploratory Data Analysis. Then we will talk about data cleaning and then outliers. And the next outline we have is data preprocessing. And then we have the outline of class imbalance. And then the last, we have a capstone project that will summarize whatever we have studied in this course and all of the above outlines. So let's move forward. Before we move towards the outline of exploratory data analysis, first of all, let's have some recap and learn what is data science. So data science is a discipline that employs statistical and computational techniques to derive insights and understanding from vast and intricate datasets, drawing on a blend of abilities from various domains such as statistics, mathematics, computer science, and specialized knowledge. In real life, a lot of data is collected and maintained by organizations that is usually used in the form of datasets, and a person can be from any field who can do the data science work having some basic knowledge. Like a person can be statistician, mathematician, or he can be a computer scientist as well. So, what are the goals of data science? The fundamental objective of data science is to convert unprocessed data into valuable insights and knowledge that can be leveraged to enhance decision making, optimize workflows, and foster innovation by following a multi step process encompassing data collection, data cleaning, data preprocessing, data analysis, data visualization, and the construction of predictive models. So you have learned that data science is used to make important decisions that can help a business or organization grow. So let's move forward. Now you might be wondering that where it's used or where it can be employed. Data science finds applications in diverse sectors including finance, healthcare, marketing, and social media. Some of the typical tasks performed by data scientists include data mining, machine learning, statistical analysis, and data visualization. As data continues to grow exponentially, data science will become increasingly important for organizations to extract value from their data and gain a competitive edge in their industries. So, what are the prerequisites for this course? Some prerequisites for this course are mentioned below. That includes basic knowledge of programming, like you must know how to use or how to create variables, lists, arrays, and these kind of things in R. So you must also have some basic statistical concepts, like you should know about mean, median, mode, and standard deviation, and the statistical things like linear algebra as well. And next we have the understanding of data structures, like what are data frames, what are factors, and so on. So let's talk about the very first outline of EDA. Exploratory data analysis, or EDA, is a crucial step in the data analysis process that involves the exploration and investigation of data to identify patterns, relationships, anomalies, and trends inside the data. EDA helps in understanding the underlying structure and characteristics of the data and enables data scientists to make informed decisions about subsequent analysis. Now, what's the importance of EDA? The importance of EDA lies in its ability to provide a comprehensive understanding of the data, including its distribution, central tendency that includes mean, median, and mode, variability, and outliers, before applying any advanced analytics or modeling techniques. So EDA enables data scientists to detect errors, inconsistencies and missing values and determine appropriate methods for data preprocessing and feature selection. So that is why we do EDA on a dataset. Now, what are the objectives of EDA? The objectives of EDA are to summarize the main characteristics of data using descriptive statistics and visualizations, identify patterns in the data, and testing hypotheses in the data, and evaluate the integrity or quality of the data. Determine appropriate modeling and analysis technique. So now it's time to move towards our studio to do some practical work. Alright, so first of all, you can see I have set my working directory here, which is the data size R. And in this working directory, first of all, I will create a variable in my file with the name of cars, and I will use the function of read.csv to read my CSV file, which you can see here is with the name of cars.csv. All right. Now let's say I want to examine my dataset of cars, and I want to see that what are the columns and rows contained inside this dataset. So I will use the function of head, and here I will say cars. All right. So you can see the 6 rows in each column. You have the column of make, model, year, and so on. So by using the head function, you can see the first few rows of your dataset and also the columns. Let's say I want to see the first top 10 rows of my dataset. Then I will say head, cars, and I will give a number here. Let's say I want to see the 10 rows, I'll say head 10. You can see the output of 10 rows here. Now, what about watching the last few rows of the dataset? For that purpose, I will use the tail function. As you can see that you're seeing the row of 11,914. Now let's move forward. Let's say I want to see the dimensions of my dataset. Then I will use the function of dim, and here I will say dim cars. You can see that you have 16 columns and 11,914 rows. So that is how you can get the shape of your dataset. Now, what about seeing the column names of my dataset? I will use the function of col names, and here inside the function, I will pass the name of my dataset. You can see the names of your column here. Now let's say I want to get more information about my dataset. Then I will use the function of str, that stands for string, and you can see the data type of your variables or features. Now you have the variable of make, that stands for character. It means that this column contains strings, and model is also character, and the data type of year is int. That means this contains the data type of integer. So that is how you can see the information about your data set. This function is similar to the function of info in Python. Anyway, let's move forward. It's time to do some statistical analysis on your dataset. Let's pick a column of highway MPG. So I want to see the miles per gallon, and I would start with mean. So R has a built-in function to calculate the mean value. So inside the mean function, I will say cars dataset and take the column of highway MPG. You can see that the mean or the average value of all of the car values instances is 26.6. Now what about saying the median value? So I will say cars and take the highway MPG feature, and you can see that the median is also 26. Now let's try to find the mode of the variable. So first I will say mode, but I have to define a custom or user-defined function to find out the mode. All right. So here I'll say empty equals to unique and find the unique value of exit first and then md, and I will use the function of which dot max, and inside that I will say tabulate, and inside the tabulate function I will use the function of max, and at first I will pass the argument and then md. All right, and here I say mod, and inside the function I will say cars and take the highway MPG variable. All right, you can see that the mode is 24. Similarly, you can use this user-defined function for other variables such as transmission type, and we can see that the mode of transmission type is automatic. It's not manual. Now, let's say I want to see the variance. So that's quite simple. I will just use the variance function. And similarly, I will say cars highway MPG. And that is how I can also see the variance of the variables or the features of my dataset. You can see the variance is 78.55. That is quite a bit different than mean. Anyway, next, let's say we want to see the standard deviation. So I will say cars highway MPG. An SD function can serve that purpose for you. Now, you have learned how to do the statistical analysis as well. Now, let's say I want to see the unique values inside some of the feature of my dataset. Let's say transmission type, for example. And you can see that the unique values in this feature are manual, automatic, automated manual, direct drive, and there's an unknown value as well. Next, let's say I want to see the occurrences of each of these values. So I will use the function of table. You can see that there are 626 automated manual, and the automatic is 8,266, which is the highest. And that is why you can see that the mode of this feature is automatic. So in the last, we will just see one more function to do the exploratory data analysis, and that is the core function. That is used to find out the correlation between two variables, if they are related or not. And this function simply tells us the correlation between variables. So at first, I will pass cars highway MPG, and here I will say cars MSRP to see the relation between these two variables. You can see that the correlation value is minus 0.1. That means that highway MPG does not have anything to do with the price of the cars. So that is how you can also find out the correlation for other variables as well. Now, let's get back to slides. All right, so this is the end of today's lecture. You have learned how to do the exploratory data analysis on a dataset and its variables. So this is your homework. Find the data types of the dataset and use the functions we have studied today, and do the statistical and descriptive analysis by doing so. And here's the link of the dataset, which you can access with just one click. Now, good luck. See you next time.